All right, let's dive into one of the biggest puzzles in big data. How do you group and join gigantic data sets without bringing your whole system to a crawl? Today, we're going to look at the advanced tools in Apache Spark that make this not just possible, but efficient. So you probably come from the world of SQL, right? You're a master of joins, you can connect tables in your sleep. But what happens when your data is so big it's spread across a whole cluster of machines? Yeah, a simple SQL query isn't going to work anymore. So how do we take that power we know and love and apply it to the world of big data?
First things first, let's start with the most basic challenge. How do you get your data organized when it's all living inside one single massive collection?
Imagine you've got this huge list of key value pairs. Maybe it's user IDs and every click they've ever made, or product codes and all their sales records. The big question is, how do you pull together all the clicks for just one user, or all the sales for one product, when that data is scattered all over the place?
Well, the answer is a fantastic little transformation called groupbykey. It does exactly what it sounds like. It zips through your entire distributed dataset, finds every value tied to a unique key, and bundles them all up together into a new collection.
And this example right here shows it perfectly. On the left, in our raw data, the key 3 is there twice, right? With a 4 and a 6. Now, after we run groupbykey, look at the result on the right. Key 1 points to a little list with just its one value, 2. But check out key 3. It now points to a single list that contains both of its original values, 4 and 6. It's a super powerful way to consolidate your data.
Okay, grouping inside one dataset is cool and all, but what if the data you need is spread across totally different sources? Let's up the difficulty a little.
And this happens all the time, right? You might have your user profiles in one giant file and all their recent login activity in another. You still want to group everything by the user ID, but now you have to pull from 2 separate places. How on earth do you manage that? For this exact problem, Spark gives us co-grouping. You can think of it as a group by key that works across multiple datasets. For any key that shows up in any of the RDDs you're working with, cogroup will grab all the values for that key from each dataset and put them into their own separate lists.
Let's see how this plays out. Take a look at key 1. It exists in both RDDs. The output gives us a pair of lists. The first one has the value from RDD1, which is A, and the second list has both values from RDD2, X and Y. Now here's the cool part. Look at key 2. It's only in the first RDD, but cogroup doesn't throw it away. It includes it and just gives you an empty list for the second RDD. This is so useful because it means you never lose any of your keys.
Okay, so from grouping, let's make a natural jump to something that's going to feel very, very familiar if you have any SQL background at all, the inner join.
This is the classic database problem, isn't it? You have 2 tables, let's say store addresses and store ratings, and you only want to see the stores that you have both an address and a rating for. How do you merge those 2 lists and just get rid of any of the incomplete entries? In Spark, the join transformation is your go-to. It's a direct one-to-one translation of a SQL inner join. It smushes 2 datasets together, but, and this is the important part, it only keeps the keys that exist in both datasets. If a key is in one but not the other, it gets dropped. Gone. This example makes it totally clear. So we've got addresses for Phil's, Ritual, and Starbucks, and we have ratings for Phil's and Ritual, but oops, nothing for Starbucks. When we run the join, you can see the result. The address and rating for Phil's and Ritual get combined into a new pair. Perfect. But notice who's missing. Starbucks. It's gone because it didn't have a matching key in the rating RDD. That's a textbook inner join. But what if you don't want to just toss that data away? I mean, the real world is messy. Our data sets are almost never perfect, and that's exactly where outer joins come into play.
Let's go back to our store example. Maybe it's absolutely critical for your business to have a complete list of all your stores, even the new ones that don't have a rating yet. How can you do a join but make absolutely sure that every single record from your main store list makes it into the final result?
This is precisely the job of an outer join. A left outer join promises that every single key from the left dataset, the first one you specify, will be in the output. If it can't find a matching key in the right dataset, Spark just fills in the blank with a placeholder like none. And as you can probably guess, a right outer join does the exact same thing, just in reverse. It keeps everything from the right dataset.
This slide is awesome because it puts the 3 joins side by side. In the regular join column, Starbucks is just gone. But look at the left outer join column. Assuming our store addresses are the left dataset,
There's Starbucks. It's included, and its missing rating is just marked as none. Now, in the right outer join column, since Starbucks wasn't in our right rating dataset to begin with, it's dropped again. Seeing them all together like this really helps you pick the right tool for the job.
Okay, we've covered the what. Now let's talk about the why. How do these tools actually perform when the pressure's on in a real-world scenario? So here's a classic big data headache. You've got a gigantic table of user data, we're talking hundreds of gigs, and it doesn't change very often. But then, every 5 minutes, a new, much smaller log of user events shows up, and you need to join them. If you just do a normal join every time, you'd be shuffling that massive user data set across your entire network every 5 minutes. It would be an absolute performance nightmare.
The trick is to work smarter, not harder. Here's the pro-level approach. First, you load that huge user dataset. Then, and this is the secret sauce, you use partition by to pre-organize that data across your cluster by its key, the user ID. Think of it as a one-time setup cost. After you do that, every time a new, smaller event log comes in, the join becomes ridiculously efficient.
So what's the big win here? Well, because that huge user dataset is already sorted and partitioned by its key, Spark knows exactly where to find the data for any given user. It doesn't have to move that giant table at all. It only has to shuffle the new, tiny event data. Each event gets sent directly to the machine where its matching user data is already waiting. This one optimization can make your job run orders of magnitude faster. It's a total game changer.
So there you have it. You are now armed with the core patterns for grouping and joining data at a scale that would make a traditional database just give up. The only question left is, what are you going to build with it? What complex questions are you going to answer first? We really hope this breakdown was helpful. If it was, do us a huge favor and hit that like button and subscribe for more deep dives into complex tech. Thanks so much for watching.